students, welcome back to the discussion on the chapter Electrochemistry, and we are continuing our discussion with respect to corrosion. And in this module, we are actually going to discuss about the methods of prevention of corrosion. Alright, so let us get into the discussion of these methods of prevention of corrosion, of which very first is the barrier protection. Now students, what do we actually do in barrier protection? The corrosion takes place when the atmospheric gas is attacking the metal surface. That means when it comes in direct contact with metal surface, right? So what do? We create a barrier between the metal surface and the atmospheric gases. And how do we create this barrier? It is through applying paints or lubricants or by using electroplating over the metal surface. Okay, so that was one of the method of prevention, that is barrier protection. Next is sacrificial protection. Now what do we actually mean by sacrificial protection? It literally means to sacrifice. So we sacrifice one metal to prevent corrosion of another metal. So here iron, one of the example is iron is coated with more active metal. When I say more active metal, it means that active metal has got relatively higher oxidation potential. For example, let us consider here oxidation of zinc ion. So here zinc gets oxidized to Zn2 plus 2 electrons. But if I write its opposite reaction, that becomes reduction reaction. So E naught reduction for zinc is minus 0.76 volts. So obviously its oxidation potential will be plus 0.76 volts, right? However, for Fe2 plus getting reduced to Fe, the E naught reduction value is minus 0.44 volts. Alright, so it is quite obvious that the oxidation potential of zinc is higher compared to Fe. So when the atmospheric gas comes and when the Fe and zinc are in direct contact, zinc will preferentially get oxidized. Alright, so zinc undergoes oxidation in preference to what? Iron. I hope that is clear to you all. Next is something which we call electrical protection or cathodic protection. It is precisely useful for the prevention of corrosion of underground pipes which are 24/7 in contact with either water or water vapors, or you can say moisture, right? So here in this case, the underground pipe, we connect it to the active metal over the ground, okay? And that active metal now, because it has got the higher oxidation potential, will behave as anode, and eventually the underground pipe will be compelled to behave as cathode. Alright, and we all know that at cathode actually reduction takes place. So we avoid the oxidation of underground pipe by converting it into cathode. Alright, and how do we do it? By connecting it to the more active metal. So I hope students you have got the clear idea with respect to the electrical or cathodic protection. Next is the anti-rust solution. Students, we know that the corrosion takes place. It is accelerated in presence of acidic medium, right? So the anti-rust solution is the highly alkaline solutions of phosphates or chromates, which will remove the acidic environment from the metal surface and also will provide a kind of a protective coating over the metal surface, so which will act as a barrier between the metal surface and the atmospheric gases. And finally you have the passivation. Now students, what do we actually do in passivation? We have a metal surface, and even before the atmospheric gas oxidizes the metal surface, we oxidize metal surface. How do we do it? By using very strong oxidizing acids like HNO3 or H2SO4. So you have a metal surface, we treat it with very strong oxidizing acids. These oxidizing acids will oxidize the metal surface and will form its oxide. The oxide of metal itself will form a coating over the metal surface so that further oxidation will not take place. That was the process of passivation. So these were the methods of prevention of corrosion. I hope students you got a clear understanding of this particular module. Thank you all.